Okay, today we are going to be looking at some more work on the Pythagoras theorem. In this case, we're going to be trying to find out the length of a shorter side. All of the practice questions we did last week, we found the longest side, which was the hypotenuse. Remember, the hypotenuse is the side opposite from your right angle. That was the side there. And the hypotenuse, sometimes called h, in the formula that we were using, we were calling it a c. It doesn't matter what it's called, it's always the longest side and it's always opposite the right angle. The formula that we were using to show the relationship between the two shorter sides, A and B, and the longest side, C, was C squared is equal to A squared plus B squared. And we were using that with known lengths of A and B to work out how long C was, this longest side here. With a little bit of rearrangement, we can use this formula to calculate the length of A or B as well. So I'll show you how to do that. We're just using a bit of algebraic rearrangement, so we're going to subtract A squared, first of all, from both sides. Remember, to keep an equation balanced, you have to do the same to both sides. So I'm just going to subtract A squared from both sides. That is going to give me C squared minus A squared is equal to B squared. And then I'm just going to flip that round because it's always easier if our subject is the first thing that we're looking at. So it's B squared, C squared minus A squared. So what that tells us is that if we know the lengths of C and A, then we can work out B. And it doesn't matter which way round we labelled up A and B. Remember that from last week as well. So I can do the same thing. I'll just do it in a different colour. I can do the same thing to find the formula for A. Because we start at the same point, C squared is equal to A squared plus B squared. Instead of subtracting A this time, I'll subtract B. Well, B squared. And that will give us C squared minus B squared equals A squared. Or if I flip it around, A squared is C squared minus B squared. Now, the important part to remember about this isn't the A's and B's. That doesn't really matter. Because you can call the A and B either way. I could have called this one at the side here A and this bottom one B. It doesn't make any difference. They're the shorter sides. They're kind of interchangeable as far as where you put them in the formula goes. What is important when you do your rearrangement is that it's the short side that you're looking for is equal to the long side squared minus the other side squared. So this A will be the other short side. The same with B is the other short side. So when you're trying to find it, it's the short side you're looking for. And this one's B. Is the long side squared minus the other short side. So if you're told the longest side in a question, and you're asked to calculate one of these other sides, it's always going to be the long side squared minus whichever side you're given on the short side. Will tell you the third side of the right angle triangle. Okay, we're going to do some practice ones. I'll let you see that in action. So this first one, we're asked to find the length x. We know the long side is 5. We know that's the long side because it is opposite the right angle. If it helps you, you can draw in that little arrow on the diagrams. It's perfectly acceptable to do that. That's just you highlighting to yourself and to whoever's marking your question that you know which side is the longest side and why it's the longest side. So we know that A squared is the longest side minus the other short side that we know. We'll label them up. C, A, and B. As I said before, it doesn't really matter which one's A and which one's B. What you're looking at is the one that's on its own is the one you're trying to find. And then we have the longest side subtracted, or with the other short side subtracted from the longest side. So it's C squared minus B squared. A long side minus short side. Okay. So what we can then do is A squared is equal to 5 squared minus 4 squared, which is 25, minus 16, which is 9. And that's A squared equals 9. A is going to be the square root of 9. So A is 3 centimetres. Okay. Do another one. This one has some slightly bigger numbers, but the process is exactly the same. So we're going to have a short side because we are given this long length here, the hypotenuse, opposite the right angle. We're given that as 45 centimetres. So it's going to be the square of this side here is going to equal the square of the long side minus the square of this other short side. So I'm going to just use A squared is C squared minus B squared. So just calling that one A, that one B, and that one C. And with the exception of C always being the longer side, doesn't matter which round you do A and B, you would just put the numbers in the right place here. So the bit I'm trying to find is X. So substitute into that. I know the longest side is the 45, so that goes next. And then the other short side is here. Okay, we put that into our calculator. .45 squared is 2025. 27 squared is 729. Which gives us 1296. But remember, that is your x squared, so we have to take the square root of that. So the square root of 1296. Put that into your calculator. That comes out at 36 centimetres. Okay. It's perfectly okay to use your calculator for these. You wouldn't be expected to know the square root of 1296 off by heart. Okay, here's a final one. Again, like when last time we were using Pythagoras, it doesn't really matter what direction the triangle's facing, whether it's upside down, back to front, or sideways. As long as it's a right angle triangle, then you can use Pythagoras' theorem. And the hypotenuse, even though here it looks like it's on the bottom, is still opposite the right angle. So the hypotenuse there is the longest side, is 12 centimetres, and we're then going to use that as our C. And I can pick any way around. I'm going to do A this time and B there. Doesn't matter which way around I label these two sides. What is important is that when I then put them into the formula, I'm going to have the part I'm looking for, which in this case is B, on its own. And then I'm going to have the longest side, C squared, minus the short side that I know, A squared. So the part I'm looking for is on its own. I'm going to substitute in x squared. C is 12, so that's 12 squared, minus A is 6. 6 squared. That's 144 minus 36. So I have 108. As we said before, remember, this is x squared, so we have to take the square root of that. So it's the square root of 108. When you put that in your calculator, it comes out at 10.392, and then loads of other decimal places. And I'm going to round that to one decimal place and say 10.4 centimetres. Okay.